If now we have a velocity that increases along a straight line graph, it means the velocity is increasing at a constant rate because the slope of this graph isn't changing. And remember that the slope tells you the rate at which the velocity increases. The velocity increases at a constant rate from 0 meters per second up to 8 meters per second over a time interval of 4 seconds. What can we determine here? Well, one thing that we could certainly determine is the rise over the run. 8 meters per second divided by 4 seconds is 2 meters per second per second. That's the slope of the graph, and that's the rate at which velocity changes, and we're going to use that in a minute. However, what we want to calculate now is the displacement that corresponds to this motion. How far does an object move if it does this? We saw before that if we had a rectangular graph, we would be able to multiply the altitude, which corresponds to velocity, by the width, which corresponds to the time interval, and get the displacement. But in this case, we have a changing velocity. Well, a certain amount of common sense tells us that if we go from 0 meters per second to 8 meters per second, we're going to have an average velocity of approximately 4 meters per second. Now, if we go from 0 to 8 meters per second at a constant rate of increase, if the velocity increases along a straight line, that is, the velocity is always increasing at the same rate, then the average velocity is exactly the average of the initial and final, 0 and 8 averaged to 4, and this will be our average velocity. And we can say that we move exactly a displacement of 4 meters per second multiplied by 4 seconds, or 16 meters. Moving at 4 meters per second for 4 seconds, every second we move 4 meters. If we do that 4 times, we end up going 16 meters.